test. Okay, I seem to be live. Perfect. Hello everyone, welcome back. Sorry for not having updated the YouTube channel yet. I've uploaded all the videos. I just need to start updating the information and then publishing them. I've been quite busy, but it's all is saved. I just need to publish them now. Now, last week we've made quite a lot of progress. I got distracted last Thursday when trying to actually start making the analyze function, like starting to analyze functions. Instead, we've been doing a lot of type resolution in structs, and we even did placeholder substitution last time, which was quite fun. This evening, I want to go back to analyze function now that all of the type stuff is out of the way, and hopefully we can make some actual progress on analyzing functions for real, this time for real brackets 1_final. So yeah, that's the plan. And again, yeah, sorry again for not uploading the stuff to YouTube. Well, for not publishing on YouTube, it's all uploaded. I just need to publish it. I just haven't had the time. Okay, well, let's get started. So, last time, we started with just a very basic thing of like, hey, functions may have a return type, and we need to make sure we resolve that, and we need to make sure we take into account the type parameters of the function, because if a function is parameterized by a type t, that type t may appear in the return type of the function, and therefore we need that to be in scope for the type resolution to work. A big thing we talked about last time is since I'm considering generic functions as part of the first draft of the language, we are going to need to differentiate at some point between a generic function that doesn't know all of its types yet and one that is not generic and that has all of the type information. The big difference is we can fully like type check a function whose types are all known, but a function that has type parameters, some of the expressions we are not going to be able to type check until we know what the types are. Because I'm using kind of like a C++ approach to this, where since there is no trait or anything like this in our made-up language, I can't check that the generic type matches the requirements of the function. Instead, I just have to say when it's instantiated, hey, does this still type check with the types you have given me? For that reason, because at some point I will want to support incremental compilation, I'm going to have to make a change while we do this function resolving. I'm going to have to keep track of which functions are instantiated in the current module, because each module will need to store the full list of the functions that have to, the generic functions that have been instantiated. They can be deduplicated afterwards, but we will need to keep track of like, oh, this function is calling a generic function, therefore that one needs to be instantiated. Yeah, that's about all I have to say on the topic, so we can get started, I suppose. I'm going to do the same thing I had last time, which is I'm going to open the AST here at the top. I make it smaller a tiny bit, just because I want to have the function info here so that I know at all times what we're dealing with when here we are going through the AST. So we've already resolved the function return type, because that's already done at that point, which means we can probably, I don't know how much we'll need to carry around as extra state, but we might need to carry that along because we might need to check that the last expression of the function or that all the return statements match the type of the function. Next, I suppose we just have to go through the function body. There's one thing I haven't done a lot yet. Actually, let me check. Have I done anything with location yet? Let me see. Do I have like a with location function? I don't. Because all of my AST is annotated with location information, like where did this happen in the source code, which for now is extremely rudimentary. I don't have like a span of the actual piece of code that I can like link in my error messages, but at least I have like file name, line number, column number, which means I can keep track of that in the state of my compiler so that when I throw an error, I can include that in. I'm just curious about what do I have at this point? Do I have anything in the top level analysis function here that says no, I don't do anything about this, I think. At least not at this level. Oh wait, set scope, right there. Gotcha, so I do that with this, the local set scope. Okay. Okay. I'm not sure why I am doing this, however. Let me have a quick look at how my monad is declared. It's the problem of only working on this twice a week is I lose track of the state of things between streams. It was kind of a choice I've made of like, I will not work on this off camera, but it has downsides. I move the top level names into names. That's interesting. Is it because I want to be able to modify the names without touching? Yes, I need to keep track of the top local names. That makes sense. That being said, since I'm using local anyway, there's no reason for me to not just always use the info names. By virtue of it being a reader, when I exit the local function call, I'll be back to having the names being the top level names. So I am not sure I see the point of this. When it was in a state, that made a lot of sense. But since I am no longer in a state monad for this, I am not sure I see the point. That being said, maybe I will want to use a state monad, not the reader monad for this, even though the downside of state is it has to be manually maintained, because it's going to make it a lot easier to keep track of the changes I make based on the scope when I'm iterating over a list. Because otherwise, if I'm iterating over the list of statements and I'm using local to make the changes, I have to like make the recursion explicit rather than just iterating over something in the state monad. So maybe I want to change that. Hello, how are you? So let me think about this for a second. I'll go back to reading how the top level works. Like, when do I set top level names, for instance? I return them here from the init local names, and I suppose the top level function then does a local. Yeah, there we go, top level names. I guess, yeah, I guess this might not be. It might not be needed to look at the. Because the upside of using reader is that I don't have to make sure that every time I push something, I pop it back from the state afterwards. I just use local to alter the state for the duration of a. But that means that makes a lot of things more complicated if I do any iteration over lists. I think it's better to put it in the state, and it makes, I think, a lot more sense. What I can do, however, is keep this as top level names and move this as context names, and it gets initialized at the beginning, it gets reset at the beginning of each analysis to whatever top level names is. I think that makes a bit more sense. Okay, which means I can move. No, top level names is still here, it doesn't change. what changes is I have removed names, which is an empty map, which is now here, initialized at the beginning of the analysis. And I'm going to have to change a few places where I use info names, like here, for instance. This is going to have to be instead the context names. Context names. And here in this set scope, I'm going to change something. I am going to, because I'm not going to change info top level names. This is in the reader, it doesn't change. I am going to change, however, I'm going to get that thing, which would be a uses of info top level names, which I am then going to put into how do I write this? I guess that's a put s or something. Is there such a thing, or do I have to use lenses here? Yeah, there isn't such a thing. I'm gonna have to use lenses. So that means it is going to be, I guess I could just do it in two branches. So top level names is in two expressions is this, and then I set for the scope of the analysis of a given declaration, I set the context. I reset the context names at the beginning of it to the top level names. So each analysis starts with a fresh stack. Okay, and then I can do the local set scope, except this is only about the location, which maybe I want to not put that here either. Maybe putting this in the reader was a mistake. I think it's a mistake. I think I am going to put it here. It just means that whenever I go recursively through something, like for instance, I start a loop and I have to like manage the state for that loop, I am going to have to manage a history of the scope before and after that loop. But it becomes a lot more manual, but that's not necessarily a bad thing. The upside is if I'm iterating over a list of statements, which is going to be the case, I don't have to manually do the recursion of the list while using local for every step, which would be kind of ugly. Okay. So that means I am going to add this context location here. Actually, I guess I could. Oops. Copy and paste rather than rewrite. Which is the current location of. Why do I have locals? Why is that in the context? Why is that not in the reader? Because that's not going to change. That's the list of declarations I have not processed yet. But I don't remove things from that cache as I go through. So maybe actually, if I go back here, if I look at context locals, I do use it, but only for, look up here. That doesn't make sense, I think, to put it. It could be in the reader. because that's the stuff I am reading like it's never going to change throughout the analysis of declarations. So I am tempted to I'm almost tempted to actually split this monad, because I have, at the moment, an RWS, which is read-write state, which carries the fact that, like, okay, there's some reader stuff, which is not going to change or only change recursively as a stack, never going to be modified through a series of actions. There is the list of diagnostic, which is the writer, which is what my function can output. And there is the state, the stuff that will change from one statement to the next. But I do a lot at the beginning at the top level of the module, just with the analysis, just like setting up the analysis info before I start. So maybe, in fact, I would like to split that as a reader of the analysis info on top of the context and the diagnostic, so that all of the init of the analysis can be done purely in this. Then I get the analysis info, and then I run reader with the analysis info, rather than using local like I do at the moment. That's probably something I will want to do when I clean up this file after being done. I don't think that's something I want to do just yet. But I think I will move this to here where it belongs. Which means I have to change a few things. I think this now cannot be put in the state at this stage, which means I'm going to have to return it as a value from this, which currently returns a hash map from path to non-empty name, and now we'll return both that and the hash map from name to with location declaration passed. Let's do that. So it's going to return the context, the info locals, which I'm supposing those are the top level names, and therefore this is the locals. Name with location declaration passed. Okay. Okay. Which means now this, instead of doing the context local here, remove this now incorrect statement. And return this, or actually, locals is this. That is this, and therefore this function returns top level names and locals. Okay, which means now where this function is called, which is here at the top level, init local name here is giving me top level names and locals. And now I can do, this would be a good place, yeah, again, to have a run reader T here, rather than running everything. It's kind of tempting to do that right now. Which we need, I would need to change the signature of some of those, but that doesn't seem too bad of a problem. Also means some of the stuff that is currently in the reader I couldn't access. I'm not gonna do it now, but yeah, I'm definitely gonna leave a comment of like okay. And now I might move this to a second function. Which is going to take, what does this require? It requires the foreign names, the local names, yeah, okay. So everything we've seen so far. So this is going to be a function that, given some reader context, so which is the info thing, is going to modify it by applying a thing, which in our case is simply going to be applying a bunch of lenses. So it's going to be applying this one. It takes foreign names. I could almost make it, I could actually declare it here so that I don't have to pass all of the arguments. So I could do that here instead. So given some context, we do the info top level names is this, combine foreign maps, combine maps, local names, which is now called top level names. And we also do another thing, which is info locals. I guess set, it doesn't have to be modified. To be the locals. And I might just do it in this order because it looks better. Okay. So this, I'm combining two functions. These functions assigned locals to the info locals fields for whatever context is given to me. This function does the same thing of assigning this value to this field here. And combined, they make a function that takes a context, well, info thing, and applies both of those. Okay, so now I can do my local init reader context, which is this thing here. And now, okay. Okay, so that should be fine. Another thing I'm going to do, which is, I think, already done at the top level analysis, which is here. I do this set scope thing, which I don't think I want to do the same way. I think location doesn't have to be a stack that I modify only with local. It's perfectly fine to just, whenever I arrive at a location, set it in the state. It's unlikely that I will ever need to go back to the previous location. Therefore, this here is where I will be doing. So context name is top level names. That's fine. And now that I have a location, yeah, I probably want to do it here, analyze declaration, which is my entry point for all the analysis of any declaration. I should set the context, which is this one, location, to where this location is location of the declaration. Oh, it's already extracted here, which means I can just do this. Why is it extracted that way? Where am I using it? I'm using it here. Okay. And set scope is no longer required. And I could instead even go one step further, and instead of using a where block, I could do this and move it to the do block itself. Okay. Okay, so that's better now. I am tempted to add a convenience function for a bunch of things. I wanted to add a with location thing, but I don't think I need to do that since it's now in the state and I never need to push it back. Doing a with location that takes a callback as an argument adds no new real value. I don't think I'm going to do that in the end. Okay. I should probably, before I make more progress, I should make sure this all compiles first because it won't. Yes, the location is no longer there. Context is now 2 hash maps and an initial location, which is wrong, but that's fine. This is going to be changed anyway. And this now contains the module name, an empty stack of which is used to break cycles in declarations that reference one another. And the top level names and the locals, which is an empty map at first, which is again because for now I am running the reader before all of the values are ready, which is kind of ugly. Okay. So this would be info locals instead of context locals. Context location instead. Oh, I already do this for expression. Nice. Of updating the location. Oh, except I do it as a local, which doesn't make sense because this is no longer in the reader, which means I can do it instead as this, and I can remove this, and I can remove one layer of indentation for this gigantic function, which is the analysis of expressions for a constant. Okay. What else do we have? That seems to be all. That seems very wrong. Because I already have something called top level names, I think. And here I have this recursive definition. I'm just going to call it local names instead, which is not great. Okay. Uses info locals views. Since it's no longer in the statement, it is now uses. So views take a lens and recovers that information from the reader. Apply that lens to the reader value. Uses does the same for the state value, but since I've swapped a bunch of them, I have to swap a bunch of uses of uses and views. Yeah, this with type parameters was taking an argument because it was setting up a bunch of names in the context. Does it still make sense for it to be a with when it only modifies the state now? Because it doesn't need to undo those changes when the action returns, which was what local does. Since that's not needed, this probably no longer needs to be a local, which means it should be instead a set type parameters, which doesn't take a callback, and instead does this. Which means now I have to go change with type parameters everywhere, because this is now a do block that starts here and after this, everything is in at the same level. There we go. Same here. This no longer takes a callback. This is just in the same do block. Enums don't have type parameters. Constants don't have type parameters. Struct fields don't use that function. And now for functions, I am back to set type parameters, which again doesn't need the callback anymore. Okay. Because this is no longer a function applied on the state within a function, it needs to be at the do block level. There we go. Okay, what else am I missing? Top level names is views. Oh, it's view, isn't it? Views would apply a function to it, which we don't at the moment, I think. Context location, set to location. This is not a tilde, this is an equal. The tilde lens operators modify a value directly. The equal version of those operators go modify the value within the state. So this was an argument to local that operated on the value directly. Now that it is in a do block, it operates on the state, on the value in the state, and therefore it needs to be the new operator. Okay, that compiles. Let me just do a quick test, which is let's go back to look at our main which I think is like test 2 something. No, test 3? Most reliable test. Okay, we had this complicated stuff last time. Let's see if I... No, I was using a different... I was using... No, I don't remember. I was just, I think, directly running. There's nothing in there? No, come on. Oh, is it in stack work? Am I an idiot? It is, of course. Build. There we go. I was using the binary directly just because that way I don't have to recompile. I can use the latest version of the binary. If I do a stack run, it will recompile whatever I have at the moment, which is not always what I want. And I want to do that and call test3 main. There we go. Okay, so this still analyzes things correctly. And from last time, this monstrosity where I have a Boolean constant which is made by constructing a bunch of structures that have a type parameter which is omitted because the type can be inferred from the context. And this seems to still work because I get a Boolean expression true as the value for the constant z after all of this nonsense. Okay, so that seems to still be working, which is good. I still don't have proper tests for all of this phase because this phase is very, like, we haven't finished this phase yet. I think when we're done with the analysis, when we have enough that I'm able to move on, even if we don't have everything that I can move on to, like starting lowering into the AR, I'll take 2 streams, 3 streams, or whatever it takes to write a lot of tests for this, because having to do manual tests has been very useful, but I would like to have some more robust tests for this section. Okay. Now, we have made those changes, which means we can go back to the function that I keep procrastinating by doing other interesting things. So I guess now this is just a matter of of going through each statement in the function and analyzing that. I probably want to make that another function. I don't know how much additional context I will need beyond the context I'm already carrying. I will need the resolved type for sure. But I will absolutely want to have some other function because I will need to recurse to other lists of statements for every block I encounter. So I probably should set in the context whatever the return type is, because I am going to need that. Because yes, I can't check at the end. I can't resolve all the statements and then check that the type is correct, because early returns are a thing, and I will need to type check every single one of them. So, back to monad. Here in the context, there's gonna be a fun type, which is gonna be a maybe of a resolved type. And a resolved type is a path info resolved, which means this starts at nothing at the beginning, and it might still remain nothing because not all functions have a return type, which means I will need to check. If it's nothing, I will have to assume it's basically unit, and I will have to check that the return is empty or returning unit, basically. But since I don't have the way to express unit in the language yet, I will have to check that there is no expression for the return types. Okay, so how is it called again? It is called context fun type. Is gonna be set to the resolved type, which is already a maybe, so that's perfect. And now I can traverse, analyze block for, well, I guess traverse analyze statement actually. I don't need to do anything at the block level, I think. So this is just going to be an analyze statement for everything in the function, which is, as we have established, the function body. And this will be the result. Oh, I need to resolve the arguments. I haven't done that yet. But when this exists, this will be then resolved statements. Yeah, I mean, I need to resolve the arguments first because they are in scope. What does that mean? That means their names must be added to the current context, because there are names that might be referred to in the function. Their types must be added there as well, because we're going to need to be able to do some type checking there. But they won't be pointing to a declaration. Those are only for top level things, which means the name that they are given must contain all of the relevant information. Okay. So that means we need to start by resolving the arguments. Which is going to be a traverse of resolve args, or resolve arg singular actually, of the function arguments. The result of which will be here. This isn't going to be too complicated, I believe, famous last words, because that's just a tuple of like identifier and type, and resolving a type is something we already know how to do. We've already done that kind of stuff for a structure field. At this point, there isn't a lot to do. There's no type checking to do. This is just like, hey, is this thing a proper type name? And that's about it, basically. I'm just gonna comment this out for now so it can compile. And let's do analyze arg. Or resolve arg, I guess. Or, yes, I should be not resolve, but analyze. Resolve is a different series of functions. Here. Oh, analyze was correct. Okay. So this is going to be a function that, given a tuple that is the argument, which is an identifier and a function arg type passed, is going to give me in my complicated monad that, again, I will want to change at some point, especially because currently I'm doing all of the error handling, all the short circuiting with the maybe t thing, which is not super elegant. I will probably want to have a better way of short circuiting. Some kind of like catch system, basically, of like, oh, try to analyze this thing, catch when it doesn't work, which I can do with the maybe t thing, but it's just a tiny bit inelegant. So many things to improve when things start working a bit. And the result of this will be, of course, the same kind of tuple, because the value that will be will be in the result will be the same shape, but instead the function arg type will be resolved. Okay. So what do we do when we analyze an argument and we have as a thing a name and arg name, arg type? I think there isn't a lot more to do than just resolving. There isn't a lot more to do than just resolving the type of this, but this might be the point at which, in which case I'm not going to make it a separate function because it's going to be very tied to this. This might be the place where I also do the insertion within the scope. So I might want to do this instead to make it clear that context manipulations happen in the context of a function. So what do we do? The type of a function is slightly different from a regular type because I support, in this made-up language, a very close approximation to pass by reference. Basically, like the ability to mutate a value outside of the function. But that's going to be extremely limited. Oh, also I'm going to need to check. I'm going to need to check that the same variable is not passed by reference more than once. But that's not at this point. This is at the call site. At this point here, the two references will be two different values. That's fine. Okay, let's not get too distracted with all the things we have to do in the future. Let's look at what a function archetype is, and it's just that. Which means will I want to know if the thing was by value or by reference? I think it doesn't matter for the purpose of type checking and resolving a function. This might be good to know in the future though. So maybe I'll have to carry that information around. For now, this is very much a matter of resolving a type is doing a case on the archetype. And if it was given by value with an archetype, type, there we go. I guess this is just a resolve type T. I could almost make it. I could almost introduce a function that manipulates the type without having to actually do the deconstruction and reconstruction manually, because that's a bit verbose for no particular gain at this point. Okay. Except, of course, this is map. Okay. So the result will be at the end of this a pure of the tuple argname resolved type. But here is where we're gonna change something, which is we are gonna add it to the current names. So function argument. And the function argument is characterized. I guess I don't need the identifier for this. I might not need the identifier, although it doesn't hurt to have it. I think the most important thing I need to know is the type. So I think I will be carrying around a fun function archetype resolved. That is a problem. That is a problem because that's a circular dependency between this module and the AST module. The AST module is aware of names. And names need to be aware of. There are ways to solve this in Haskell. I have no choice. I will need to know. I will need to be carrying around that information, and in the name is where it makes sense. Unless I don't put it in there, and instead I put it in my context rather than overloading the name for this. That might make more sense, actually. Yeah, maybe let's do that. For now, at least. When we clean things up at some point later, we can always change a few things around. So I will want to add for the context here fun args, which is gonna be a hash map from identifier, from identifier, because the name carries the identifier anyway. Hash map identifier to the resolved function archetype. Okay. Which means one more hash map in the context. That's fine. Also means that back in the analysis, I need to go back to. Or I guess I can do it at the beginning of the function. Since it's never used outside the function, I could do it here. But I think it's better to reset it for every single declaration, just avoid polluting the context for other things. Here, when I reset the thing, the context name becomes top level names, the context location becomes top level location. The context fun type is reset to nothing, and the context fun args is reset to, which makes me almost wonder if I should have a state over a state, or if maybe even this thing, this analyze declaration, should be where I do the run state, and I should run with a fresh state every time, because no, there is state that is being carried around from declaration to declaration. So yeah, this is the best option, I think. namely the cache of what I've already done is being carried around in the state. I could stack state over state, but that becomes a bit ugly. Okay, so now we've resolved the type of an argument. We're ready to return it so they can be inserted in the resulting function declaration. The last thing I need to do is I need to set that there is this variable in the scope, and I need, so that's the definition, like for a given name, that's the thing, but I also need to add it to the list of names so that all of my resolving functions work, and that would be adding it to the context names, doing this operator actually. Oh, there we go. I'm gonna insert with actually, oh, that's interesting. What happens if I have a function argument that is already a name in the scope? There's a constant named foo and a function argument named foo. What do? I don't think that's an error. I think that's a warning. That's a shadowing warning. So I could do, I think I do something similar for types. So I could go back to set type parameters and see what I do for those. There we go. Oh yeah, I also check, I can do the same. Perfect. I'm just gonna copy this whole block for now. So yeah, I should probably do that afterwards, when all the other checks have been performed. So what do we do here? If the identifier is reserved, so if this function is, like if the function argument is name int or something like this, which is not valid, ooh, I keep doing this. I keep stacking more things on top of the things I'm already doing. There is a thing I'm not doing at the moment I need to do, which will be in batteries, I think is the name of the folder. Built in, there we go. Currently, my list of reserved identifier includes all of the type names that are special, but that's not all of it. I need to add more to this. The keywords of the language are also reserved. Because if someone tries to name an argument name function or something like this, it should not be allowed. Actually, that's already handled by for me. I don't have to do this because our Alexa would parse this as a keyword, not as an identifier. Therefore, if it's successfully lexed as an identifier and we make it to this point, it means it wasn't a keyword in the first place. I don't need to handle that. Okay. So when it's reserved, okay, that doesn't change. Let me just check the type name is in scope. I'm going to rename this to actually function name because it's not a type name. Then the parameter name is not correct. It's going to be the argument name. And as we have decided in the name thing, this is a function argument. And now this is where, instead of looking at a type, I'm going to try to resolve the name. See if there's any name in scope for this. Matching identifiers. Interesting. For type parameters, I only check that this shadows other types. I don't check that this shadows any other name, I think. Is that correct? Which means if there's a function named foobar in the file and I declare a struct with a type argument named foobar, same case, that won't be a warning because that doesn't shadow another type that shadows a constant, which is fine at type level, I guess. Let me think for a second. I think that will not lead to ambiguities in the sense. Now it will lead to ambiguities, actually. Aha. Okay, I can probably make an example that replicates this. I can probably do that. Okay, let me comment this out because it was a bit of a complicated nonsense. Let's imagine I have a constant t, which is an int, which is equal to 0. Oh, but constants can't have... Constants cannot have type parameters. So does this still work? But functions can. But I have no way to test this yet. Okay, bear with me for a second. If constants could have a type parameter, something like this, something like this t would not be resolved to be this constant. It would be like an error because that's a type in this context. Which means, which is fine, but that means this should give me a warning because it is shadowing a value. At the moment, I think it only gives me a warning if it shadows another type. Because when I do a set type parameters, I do a resolve type maybe to try to see if there is any matching type in scope. Or is that an issue that it solves? Is that a problem? Where is this resolve type maybe? There it is. Does it make sense to check collisions for things that are at the same level, value level or type level? Or is it better to make a warning if things shadow something else regardless of the scope? I don't know. It might be better to only do the warning for the same scope, I think. Because ideally, I would like to be able to distinguish between, oh, I am at the value level, therefore I should look into my value cache, therefore, against versus I am at the type level, therefore I should look in my type cache, which would allow constant and types of the same name to coexist, which they cannot at the moment. I think, given the fact that at the moment types will shadow values, value will shadow types, I think I have for now to emit a warning whenever something shadows something else, regardless of whether it's at the type level or the value level. I think that's the only sensible thing to do. So I'm going to comment this out. And instead of resolve type maybe, I think resolve name will be what I want. Which is just the resolve name. Is it resolve path that I want? I guess this is even simpler. I just want to do a lookup of the identifier and check if there's already things in scope. So I think I just want a lookup path. The type resolution mode is about allowing, which I don't think is required here, because it's only used for, yeah, that's not required at all here. I think that's just the only thing I need. I need for an identifier, give me a list of name. And I don't need to know what kind of thing that is. I don't need to know if that's a type specifically. I'm not looking for a struct specifically. I only care about, and this is actually a, no, it isn't, a list of, here do I make it? Because what is stored within the context names is a non-empty list in the case where there's a hit. So I could represent this as a maybe non-empty list, which kind of is the same thing as a list, where the maybe case covers the empty case. But I think it's better, it's more explicit to handle this as a maybe non-empty list of name. So I'm gonna do that, even though it's again equivalent to a list. And this is just, is it just, yeah, it's just that. On the context names in the state, apply a lookup of the given identifier. That's it. Okay. So now I can go back to type parameters. Where are you? There you are. Matching names will be a lookup path, which I guess I could just call lookup identifier. It's not even taking a path as an argument. Identifier. And in this case, I can do, oh, do I have when just in scope? This is when just, if I open Google, and I put it to the side so you can see it. When, oh, I can't type, I swear. When just would be this, which is, let me, given the maybe A, apply this monadic callback function on the A if it's present, basically. And it is in control monad extra. Do I have control monad extra in my dependencies already? Be it extra. It is already there. Perfect. Is it in my prelude already? It is not. Okay. So just need when just for now. And go back to set type parameters. When just matching names. And I'm going to change here this since I have made the call for now that since I don't have a separate cache, values shadowing types and type shadowing values should both be included. This is going to be a name shadow or identifier shadow, but like that's fine for now. Yeah, for now this is going to be good enough. Our error handling will need a lot of work. We are in stages analysis, and this is going to be in diagnostic, and warning type shadow is actually warning name shadow. Okay. Which means I can copy that back and put it back here at the bottom of the file in the thing we were doing in the first place. There we go. If it's a reserved identifier, we fail. If the argument name is already in the names, there's already thing with that name in the scope, we fail with a warning. There's one more thing. I need to check that the name of the arguments are not duplicated. So I need to also... Is there when just M? There is! Perfect. Which means I could do when just M this and not have to do a temporary binding, and also this is not matching names, this is names. There we go. And I can do the same thing when just M uses context fun args with lookup of the argument of the arg name. If that gives me a just value, that means I have found an existing name in my scope for that argument, which means a previous argument had the same name, which is not allowed, which means here I can report error, which will short circuit error duplicate function argument or something like this, and with just the argument name. Downside of this approach, rather than looking ahead of time at like a set, a multi-map or something like this of the arguments, is I will report one error on the first argument that's duplicated, and I'm not going to continue, which means I will be only reporting one error in the case of a wrong argument. So maybe I should actually do that first. And let's do that first. So here I am going to start by doing this is going to be a hash map from list with union. And what I'm going to do is for each arg name and whatever the type is, it doesn't matter, in the list of argument, which is the fun args, I will create a hash map. Or do I want to make a hash set? Nah. From list with plus, there we go. I will make a hash map, arg name, and 1. Which means this is the number of occurrences of that name, and if the same key appears more than once, we combine the values with plus. Now, what I'm going to do is report an error for each one that appears more than once, and then I will fail if any of them has reported an error. That way I will cover all of them in one go, and I'm not going to make the user find one duplicate thing, recompile, find another one. I'll bundle the errors together. To do that, I guess the easiest way to do that without having any helper function in the way for now would be to do something like this. All valid, which is going to be the result of doing an AND on a list obtained by doing for each value in arg names, which, as we know, is an arg name and a count. Count will shadow something else, so let's not use the name count. Arg count. And what do we do for each of them? We return arg count equal 1, which means it appears only once. Anything else is a weird error. Well, either it's 0, it's a weird error that shouldn't happen, or it's 1 and 1, it's just duplicate. And when it is greater than 1, we do not... Okay, I need to change something here. I need to have a look. I think it's just a tell. In the writer monad, and for now I don't have a proper error handling thing. I don't have something that will take the current location, the current information, and make a nice error. It is just the raw diagnostic, and for now the raw diagnostic will be error function duplicated arg with the name of the function, which is just... It's just an identifier, I suppose? Or do I give the name of the function? The name of the function probably makes a lot more sense. But do I have the name in scope? Maybe just for now. For now, it's just put the identifier, which is the argument. We'll do error handling later. Okay, so this is going to be an error duplicate. All right. An error function duplicated arg. And that's with the arg name. So this doesn't short circuit, this continues. However, at the end, I do an AND on all of the values, which means I will only get all valid as true if I will only get AND valid to be true if all of them have been true. And then here, unless all valid short circuit, which I don't have an alias for, now it's just M0. Okay, so now that means I don't have to do that check here. That's already been performed. I'll have to adjust my imports because I've imported when just and not when just m. This file is getting very big. Sorry for the flash when I'm scrolling all the way back up. So now we've checked that there is no duplicated argument name. We've issued a warning if the name shadows something that is existing outside. We issue an error if any argument actually shadows something else. Again, we should probably do that at the same time so that we don't get one error at a time. Again, Probably better error handling would be very nice. We don't have that yet. I think that's about it. So just I need to add an argument done context name, and I need to decide what the name is, and the name is a function argument with the arg name. And I still need to return this because it needs to be part of the function information, which will be used when another module uses a function declared in this one, and I will need to make checks against the resolved version of their function. Okay, so that's argument analysis done, I think. Okay, which means now we can move on to this one. We are in a context, I don't have the name of the function, that is no longer relevant. It might be something worth putting into the context, but that might be part of the location information, actually. Or maybe I'll store the declaration of whatever I'm doing. Like, there are a lot of ways to do error handling properly, but this is not useful to me beyond error handling. I have instead a statement, a with location statement passed. And the return of this will be a statement resolve, because I believe we have decided that statements are no longer associated with anything at the end of this phase, because they don't need to carry type information, since statements don't have types. And they no longer need declaration, because after this phase, all errors are handled. So I think if I look at annotation, declaration, statement pass is with the location, but statement resolve is just a statement resolved. Okay. So this is correct. Let's go have a look at statement info. Rather, statement. And it is one of those many possibilities. This is where things are getting complicated. Do I want to deconstruct this here? Probably not. I probably want to do the same thing I've been doing before, which is the context location will be set to whatever the location of that statement is, and then here we need to analyze the statement for what it is. Let's see if there's any of those that's easy. A continue statement and a break statement are not too complicated. Oh, actually, maybe I'm wrong about annotation. I'll get back to that. The only thing about continue and break is they need to happen within a loop, which means and it would be good to know which loop they happen in, which means I would need to, in the resolved information version of these things, I would need to store something that lets me know, hey, the loop they're breaking from is this one. Which means I might want to I might want to actually annotate the output of statements with labels, basically, because all of those are going to be transformed basically as gotos afterwards. And I will need to know, well, this goto goes to that statement there, this continue goes there, this break goes there, and return, I suppose, can just go back to the end of the function. But I might need something like this to keep track of, like, okay, in the graph of my control flow, where does this go? That being said, control flow analysis will be done as part of the lowering into IR. So maybe at this point, the only thing I need to do is to validate that, like, yeah, no, this is valid in this context. And then, now that I know that, I will be able to do the proper control flow analysis when I'm doing the lowering into AR. Because I don't think I need to do control flow analysis as part of this phase. I think at this point, I just need to do name resolving and type checking. So a continue statement and a break statement, the only thing I need to do is, am I in a loop, basically? That's all I need to know, which is going to be trivial to know. A return statement, likewise, I don't need to introduce the notion of a label at this stage. The notion of a return, for now, since I'm not doing the control flow analysis as part of this phase, the only thing I need to do is that expression that I have here of the correct type for the return type of my function. Okay. So we're gonna need more things. We are gonna need more things. And by which I mean, in our context, for now, since we are not doing the control flow analysis and I don't need to know where a break goes, where a return or a continue goes, just that they are valid in the context, I only need to know one thing. If I'm within a loop. That's all. I'll just need to carry that around to be like, yeah, I'm in a loop, those statements are valid. No, not in a loop, those statements are not. At this stage, I think that's all I need to do. So this will be initialized to something that is false by default. Again, since I have this kind of like 2-layer of state, which is a bit ugly, but that's how it is, I will need to go back to when we start the analysis of a top-level declaration to make sure I reset all of the state, which I might make into a separate function for readability. Because it is done here. Okay, I am going to introduce here in this function, in this module, a reset state function that will perform within the analysis. Hello, how are you? This feels ugly. I'm gonna do it this way, but I don't like doing this, like making it explicitly in the mayBT just for convenience. That is just gonna do a no op like this, and reset state, which will now be alongside the declaration of the state, will be the thing that before the analysis of any top-level declaration will reset the state. Context location is the only one that doesn't need to be part of this. This is what needs to be part of this. Reset state. There we go. Here we do this. Again, if I had 2 levels of state, I could maintain the top level state for the cache and then having a state per analysis, and therefore instead of having to reset the cache, the state, I would initialize the state every time. But at the moment, I don't want to have 2 layers of state, so I'm doing it this way. Today, I am continuing what I wanted to do last week, and I didn't do last week because I did a bunch of other things instead, which is the analysis of functions. I spent some time doing some cleanup of like the context I'm carrying around and what is in the reader and everything, like everything I'm carrying around to do the analysis. And we have started with analyzing functions. So far, we have done, last time we did structs specifically in the context of constant evaluation. Because some things will be the same in the context of struct expressions within functions, but within functions, not every expression will need to be resolved at compile time. In fact, most will not be able to be resolved at compile time, so the things will be slightly different. But yeah, we did structs, and we did all of the type shenanigans, placeholder, and all that stuff, and type resolution as well. Here I did, so far this evening, basically this. Testing that there's no duplicated function argument. For each argument, putting it in the context, checking that the name is not a resolved name, and issuing a warning if the name of the argument shadows any other name in scope. And this might actually be wrong. I think this might need to be pure because the names in scope are a non-empty list. So therefore, putting just a name and not a non-empty list would not work. Okay. And so I'm done with the reset state, I think. Yep, that's done. Reset state at the beginning of every analysis. Because I've just added context within loop, which means now I can go back to here, analyze statement, and I can do that this very simple thing, continue statement is there an unless m? It exists. Oh, in GHC util monads, interesting. Oh, it's also in extra, perfect. So unless m, and what is the monadic expression that gives us a boolean that we want? It is simply uses context within loop. If we are within a loop, at this stage again, all of the where do we jump when we translate this into a series of goto, this will be the control flow analysis, which we will do as part of the lowering into IR. At this stage, we are doing a name resolution and type checking. At this point, we can just check, is this something that is valid in context? We don't know more than that, but because we're trying to eliminate all possible errors at this stage, everything that should come after should not be able to yield an error, but resolving where this goes is not something that might yield an error. The only thing that matters is we are within the loop. So if we are not within the loop, then report error, error to continue not in loop, I suppose. Something like that, and it doesn't need to have more information because when we do proper error handling, this function will have access to the current location that has been set at the beginning of every analysis of a statement. So I'll be able to pinpoint this error happened here, and then we have better location, then we'll be able to do proper error handling. For now, this is just error continue not in loop. Okay. And if we succeed, if everything goes well, the analyzed version, the resolved version of a continue statement is a continue statement because they don't have any arguments. That's all fine. Break is going to be the same. Break is going to be easy. A break statement at this stage, we only check whether we are within the loop. If we are, if we're not, we issue a break not in loop. Which I guess I could bundle as being like loop statements within not a loop or something. For now, that's good enough. And we return pure break statement. I guess the next easy one, easy big air quotes, would be a return statement. But the thing is, doing a return statement will force us to deal with expressions, and that's gonna be so much of the work. But when that's done, the rest should not be too difficult. So maybe let's do that. What do we do with a return statement that has maybe an expression? Well, we have to analyze the expression. So the resolved return expression will be a traverse, because this is a maybe, of a function that doesn't exist yet. Analyze function expression. Because unlike constants where I just made the local thing, I'm going to make it a separate function, because this is going to be some of the biggest stuff we have written, the biggest and most difficult stuff we have written so far. So this is going to be a separate function. And this is going to be done on the return expression. This gives us a maybe thing. If everything goes well, we will be returning a return statement with the resolved return expression. That's if it goes well, because now we have to check the type of this. And we have to check it against the function type. So if this is a proper resolved return expression, since it is a expression in this, it will be a typed expression as a result. Which means I can do a from maybe of the resolved return expression, or rather, no, a maybe. There will be some default type, and the thing I'm interested in is the expression type, if there was one. If there isn't, what I want is a built-in type. I want, is there a pattern for this? There is, there we go. What I want is the unit type, I suppose. And now I can look at I guess I could just instead here the fun type, rather than storing a maybe, I could store that as being always the unit type. And I could do the same thing at the beginning of the function, where when I set it in the context, I will do a from maybe unit type. There we go. And now here I have to do unless I need to get first the fun return type, which is in my monad as, yeah. Which is in my context, it's the state, so it's uses context fun type. Unless return type, I think I've said in the past, like expected on the left, not expected on the right. So expected is fun return type matches return type. If this doesn't work, then I can do a type error, which I think I already have the diagnostic for. I don't. I'm surprised. Oh no, wrong type. There we go. The list of types I was expecting is... I guess I could make a point that like the error type is valid here, but I don't think I want to do that. I think at this point it is simply the return type, and instead I got this one. Okay. I need to change one thing. I need to change... There's one special type, which is the void type, which will be the type of expressions like panic, which will always type check with everything because panic can be inserted everywhere and will crash the program anyway, so it can always type check. So I need to change my type matches function to recognize when something is void type that it matches with everything. So, again, type matches, there we go. So here I need to handle one more thing, which is if the name of something is... it's a built-in type, yes, so if it's this, basically. I don't like matching on a string like this. It's fine for now, but I don't like that. There's so many things I want to clean at some point later, but... the problem of like only working on this two times a week is I can't afford to spend more time on things that are not urgent. Well, not urgent. I can't spend time on more detours, I think. Especially if I want to iterate, I think it's better to make progress. And like I can flag this as like I should not be matching against a string. And when we have a first version of the compiler working, and with the benefit of hindsight, I can go over all of this and clean it up. Okay. So the problem with this is that I think it is correct. We resolve the expression and so on and everything. The only problem is that it requires... oh, I need to check any change in my monad. Here, actually, I could have just go there. I need to change my reset function. This is not nothing. This is unit type. Now, we are going to have to start the most difficult thing, which is analyze function expression. And that is going to be a doozy. Because this is going to need to take a with location expression passed and is going to return a maybe t in the analysis monad. Again, I want to probably clean this of a typed expression, which is the result of the, which is the annotated version of a resolved expression. Analyze function expression will take some expression which happens to have a location, so we can start with this and then do the exact same thing we've done this. And now we have to do everything. I want to check one thing first. How did we implement the one for constants, which is that big for constants? Yeah, we do the same thing of context location and then case located. Okay. Perfect. I think I want to check that what we have done so far compiles before I start doing all of this. Because it won't. I'm almost tempted, since we will never get to a point where Identifier isn't in scope. Oh, fascinating. For now, identifier is in tokens, which isn't great, but yeah, that's where it is for now. Yeah, I'm most tempted to make this compile and then commit it, because we will absolutely not get to a point where the analysis of expression in the context of a function compiles this thing. Unless I put a bunch of undefined everywhere, I guess. View doesn't exist. Oh, is it because I have... Oh yeah, I've only imported a few things here. View is welcome here as well. Info top level names no longer exist. It does. Oh, it does. But so lenses have a big problem. This make lenses thing, which is very useful, which I use here to generate the lenses of my types, is a template Haskell thing, which runs at compile time to generate code. It has one major downside. It messes up with GHC's name resolution thing, and as a result, the order of declarations in a file doesn't matter usually. I can refer here to a thing above, the thing above can refer to the thing below. It's just one big namespace. As soon as template Haskell is involved, anything after becomes, like everything in this file becomes order relevant. So here, those are where the lenses are declared. Therefore, this function doesn't have access to the lenses that are here, which is why I have the lenses declared in this very small module, so I can use them in another module where they're not declared, and therefore they don't interfere with the declaration order. I guess here that means I can do a very simple asks instead. Oh, did I make the mistake? No, I'm good. Okay. Which means I'm not using the lens, and therefore the order will not be a problem. But here I use them all away anyway, so I might as well use view, add view here like I had. And sadly, this is a bit ugly, but so be it. I put this reset state function below the declaration of lenses so that it has access to the lenses. And I need more. Do I want to just order like import everything from lens instead of trying to make a list like this? I can just hide whatever is missing. Oh, I still have a when just here. Oh yeah, I didn't replace this with an when just m, which I can do here rather than introducing a temporary thing. And also this is names not matching names. There we go. Also, I'm using unless m as well. This name no longer exists. This is fun name. This is incorrect. I want to dot equal. I want to set this value in the state. Is reserved identifier, is reserved arg name, arg name, arg name. And here I already have the argument name here, so instead of doing this, I can do argument name and arg name in the same scope. That's pretty bad. Let's call it resolved name. There we go. Okay, identifier, yep, still doesn't exist. That's still arg name. I have another of those mistake that's a dot equal. I had all of my operators wrong. Okay, there we go. Is that all of it? Nope, it is not. Lookup identifier. Ah, yes, because the names in the context names hash map are not just the identifier, they are the full qualified path. And here I'm just looking one of them, which means I need to make a non-empty list out of this identifier for it to be a valid key, which is as easily done as this. Warning shadow names. Yeah, I suppose that's a good point. That's a very good point. Warning shadow, name shadow takes a list which could be empty, which would make absolutely no sense because then there would be nothing shadowed. This should be a non-empty list of names. Resolve type. Expected path got actual identifier. That's peculiar. Okay, so this is when I analyze the argument to a function. The type of this is a fun arg or something like this. Function arg type, there we go. This is a path info. So here, when I get the path info, I do a resolve type of the path info, and it expects a path, but it says this is an identifier. I know this is not true. So why is it confused here? Is it because I use it in the wrong place somewhere? No, I don't think so. T doesn't exist outside of the scope, and T is clearly a path info of, yeah. So maybe my type to resolve type is wrong. What does resolve type take an argument? Aha, yes. Resolve type takes a type resolution mode, which at this stage, since we are resolving a name, that isn't built in, isn't it? Is it? Yes. Allow placeholder or forbid placeholder. Is basically, I'm trying to resolve a type. Is the placeholder thing allowed in a function argument type? No, it is not. So let me look at forbid placeholder function declaration. I've already used this for the return type. Perfect. I'm going to use the exact same thing. So here, when resolving the type of an argument, where was this? Too small, I think, for the stream. Let me put this back up. Here, this is resolve type with, oops, that's what I meant to do. Okay. I'm tempted for readability to put that on a new line. There we go. Okay. It's a bit ugly to have it twice, but I guess I could introduce a local helper for this. I think that's fine. Okay. What do we have here? This isn't resolved type, this is resolved type. Yes, in the names, likewise, this needs to be a non-empty list because names are qualified. What is your problem here? Huh. Oh, this might be a use, actually, not a uses, because I'm not applying a function to the lens, I'm just getting the lens. Okay. Same thing here. Same thing here. That's the end of errors in this run. Hopefully we're getting close to the end. Shadowing, that's good. We like shadowing errors. Those are only when we're pretty much done with the errors in the file. Shadows the existing binding. I'm gonna use this name thing I've used in a few places. Yeah, I think that's it. Here, expected. It is called this name now. Okay. That's the thing that was being shadowed. Ah, yes. Here, what's happening is interesting here. I am creating a hash map from argument name to the number of time it appears, which is 1, and I create the hash map by using plus to combine the values in my hash map when there is a key collision. And then I iterate over this hash map, and for each argname arg count, if the arg count is greater than 1, I report an error, and I just check that the arg count is 1, therefore the name only appears once. When we are done with those two things, the only thing we're left with is this all valid thing, which is a boolean. The type of the values in the hash map has never been expressed, neither in a function argument or function return type. At no point was the type of this constant here expressed. What the compiler is saying here is like, I have to default it to something. I'm choosing integer, which is a big int, basically. And I have W error on, so this from a warning is upgraded to an error, and the trick is easy. I just make this explicit that this is an int, and this warning error will go away. Okay, and there we go, this compiles. I am going to commit this before we try to move on to this. Also, it's already been streaming for 2 hours. Wow. So what do we have this evening? I guess this is mostly. Oops. That's about it for what we've done this evening. I didn't. Okay. Okay. And now that we've established a base level of okay, this works for this evening, let's start with this nightmare of a function. And for starters, I am going to copy and paste this, which is the equivalent version of this function in the context of constants, which is different because in the context of constants, a bunch of things are not allowed, and we must be able to resolve everything at compile time, which means we have a much easier time resolving expressions. Now, let's do that. Okay, there we go, and that means what does that mean? A bunch of things are going to be the same. I'm going to import into the context a few other functions that I have for constants. Well, import, copy and paste. I will want, I think, to reuse the same logic of like binary expression, bool expression, comparison expression, because a lot of those will use the same pattern. So having a helper function that deals with them means streamlining a few things. Oops. Oh, what did I do? I copied too much. Okay. So I will want to have those as local helper functions in this nonsense. I'm going to remove this just to have more screen real estate because I'm going to need it. And let's get started. So like from the get-go, this is already wrong, or not wrong per se. It is wrong for this context. It was correct for a constant. It is no longer true. A path expression doesn't have to be a constant, because it could be a constant or a variable. It could be literally anything in scope that has a value. So to begin with, the very first thing we're going to do, I guess if we start with this, is we are going to have to change resolving a path expression to being something that resolves to a value. Note that this cannot be a function, because functions are covered by something else. If I go to my AST and expression, call expressions are different from path expressions, and struct expressions are different as well. So I know for a fact that if we are in this case, this is the reference to a variable or constant or argument or something like this, something that needs to be in scope. So I am going to start by commenting all of this out, because that's already going to be difficult on its own, and I want to make sure I can try to compile everything I do at the moment. So let's start with this, and I'm going to introduce this helper here so that we can try to compile even if nothing works yet. So very first thing, yeah, in the case of a path expression, we need to resolve something that happens to be a value, something that can give us a typed expression. So either a variable. Oh god, do I want to do this before I've done variable? Do I want to do this before I've done let statements and other things that introduce variables in scope? Therefore, do I want to do this before I know how variables are represented in the scope? Because so far, a lot of things I've used the name in scope to look up the declaration as a type reference. Like, hey, sure, this is pointing to a constant. I need to look its declaration to be able to know its type to see if it matches. Now, a lot of the time, I will be referring to variables that do not have an associated declaration. So I will need to keep track of the type of everything, which means I probably will want to extend my archetype thing I have in my, or maybe I would want a local variable thing in my current context. It's starting to be a bit ugly. I think I need to think more about this, meaning I am not going to do it this evening. Therefore, you get commented out. Because this will be tricky. Now, can I do a cast? Cast expression is, I think, probably doable. Let's copy this out. Because as long as the recursive function exists, I think the cast is not the difficult part. Because basically, assuming that the function already exists, the trick to recursion is assuming that the recursion works, resolving the expression within the cast expression is enough to do an analyze function expression and give it the expression. There we go. Done. Now we resolve the type that gives us the resolve expression and the resolve type. This hasn't changed. This is where this is going to be a bit different. So what I'm doing here, I've copied the code from the constant expression evaluation, which is evaluated at compile time. Here, some things will have to be different because we cannot evaluate the value of an int at compile time. Otherwise, we would have a compile time language, which we don't. Some of the things in the cast will not be able to kick here. I just actually compute an actual int literal expression out of this. Here I will not be able to do this. So I suppose that the only thing I can do at this point is type checking. And basically, if the types allow for a cast, do I need to? Do I need to do some code insertion? Do I want to check boundaries in the cast? As in, oh, I'm casting a int to an enum in this function. That's perfectly valid. That's allowed. However, this resolved version of the expression now contains additional statements because it needs to be able to panic if this is not a valid value. But the problem is that I'm not at a point where I can insert a statement. I'm analyzing an expression, so I can't do that. At least not yet. At least not yet. I suppose that when I do code generation is where I could add this actually. Like going through code analysis. Oh, there's a cast there. Yeah, for the code generation, maybe from the code generation from the IR is where it makes a lot more sense rather than doing it here. That being said, no. If maybe I want to do it at this point because I want to be able to detect when I do the lowering into IR, when I do the control flow analysis, I want to be able to detect that, hey, this thing might panic. The problem is doing a rewrite means introducing new variables, and that's not something I want to do at this stage. I guess I could. Likewise, I have to think about it. I think the easiest solution there would be to replace the cast with a call, like with another expression, therefore not introducing new statements, keeping something that just gives me an expression back with the proper type, but replacing this to a call to a built-in function, to a special function that will be built in with the thing that users don't necessarily have access to, which is the enum cast function that will perform the boundary checks. Again, filing this for not gonna do it this evening, that's too complicated for this evening. But I can still do some of that logic here. This is the case where both the source value and the target value are enums, which means the cast is allowed. What do we do in this case? It will depend on the runtime value. Therefore, the value that we will return, the expression we return, will be our special cast or whatever it ends up being. So here I don't have. Could I do constant unfolding at this point? I should do constant unfolding at this point. Oh, this is going to add a layer of complexity. As in, if all of the arguments to this are constant, I can resolve this at compile time. I don't need to insert code for this at a later point. I think this is the right place to do this, because I am doing all of the type checking in the first place, meaning I am best equipped to know, oh, those things have the right type and their expressions are compatible. Simplify. So not only do we have to deal with like inserting runtime code for like, oh, runtime checks basically, we are going to have to check the constant unfolding. That is going to be interesting. So yes, I think this is this. I'm gonna keep this thing. And this case is basically, oh, I have a literal as the argument. That means I can check the cast at compile time. I can replace this with the proper value at compile time. Therefore, I do it at compile time. I do the constant unfolding at this point. Otherwise, insert runtime check, thing we will do next time. So here, I can move this check here. Otherwise, I can return a pure typed expression of the resolve target type with an int literal expression. Okay. And here, this second case is no longer an internal compiler error because it is perfectly valid to have runtime values that can't be known at compile time. And here, we will need to insert a runtime cast so that at runtime, a invalid cast just gets detected. I think we want to do that. I don't think we want to let, I guess casts are not checked, and maybe I could just let casts be unchecked and give instead built-in function for checked casts, or put them in the prelude implemented in the language because I should provide ways to check the size. It really depends on how I want to do things. I think Rust does this thing where like casts are checked at a runtime in debug mode, but not in release mode, which we don't have a notion of at this point in the compiler. Yeah, I need to think about this. For now, undefined. We're not going to make progress on this evening. Here, I'm going to copy all of this. This is all. I might want to introduce a new helper function for this. Because I'm doing the same thing in a bunch of places, which is usually the sign that a helper function could be useful. So takes an int value and takes an enum info and does this basically. So type name, enum name, enum info int value. When the int value is less than 0 or it is greater or equal to the length of the enum values of the enum info. Destination enum, what's the difference between resolve target type and destination enum? It's a maybe enum. Interesting. Oh no, it is the actual enum. It is the enum info. Okay. So that's the enum info. Int value. And otherwise, we can happily report enum name, enum type, I suppose. Okay. This is the compile time enum cast. So now I can replace this as being a compile time enum cast with the resolved target type, the destination enum, and the integer value I. Perfect. Likewise, I can do the same thing here. This goes away, and in this case, we are not in a cast error. That is no longer the case. This is perfectly fine because. Oh, wait. This is not necessarily completely fine. I need to check that the target. So we know the target of this expression is not an int value, but I still need to check whether it is a valid type. Because it's literally any other expression here that I'm trying to cast to an enum. The only things that are valid to cast as an enum, knowing that I've tried to resolve the type of this and it is not an enum, so I'm not in this easy case here, I still have to check that it is one of those. So here I have to do, in turn, I guess I can do it as a case resolved. I can do it as a tuple, I guess. And that way I can express this as like, no matter what the reported type is, if it is an int literal on the right hand side, I can do a compile time cast. Regardless of what type is reported, I know what it is, but I don't need to check it. If it's a character literal on the right hand side, I can do in the value, I can do a cast at compile time. If it's a Boolean literal expression, I can do a cast at compile time. Otherwise, if it's none of those, then the type is relevant. Oh no, this is not it. Correct, there we go. Now here, however, I can do check on what the type is, and I can check that this is an int type. That's valid. Insert runtime cast. Undefined for now. The character type, if we have decided that the expression is of type character type, we do the same thing. If it is of type Boolean type, we can do the same thing. But we still have to handle a few more. Because in the any other case, this is not necessarily yet something that we have to report an error where like, oh no, this cast is invalid. Because the value of the cast could be the type of a panic, in which case nothing's going to happen. This is unreachable code. It could be a type that is a type parameter, and therefore we don't know yet if it can be cast to the destination yet, because it will depend on what that function is instantiated with. So here we still have work to do. We still have to decide do I get the name? I have the resolve target type. So I guess here I have to... Wait, this is a resolved type name, which means this is a name, which means I can continue matching on things. Okay. If this is a template... Haskell. Let's me have a look at the names. Because if it is a type parameter, then it must succeed. So if this is a type parameter, whatever, then this must succeed for now, because we will check this again when this function gets instantiated. Okay. So in this case, I suppose I can just, for now, since type checking always succeeds with type parameters because they are not checked at this point, I guess in this case, this will be the same thing we do here, which is this. Yeah, sure, this value is forwarded, whatever it was, it is forwarded back as a as whatever it is. No cast is performed because that value is at this point becoming irrelevant. Type checking will not succeed. Well, will be delayed until we can actually instantiate the function. Okay. What else do we need to handle? I think we need to handle panic. Because the result of this is unreachable in the first place, meaning it doesn't matter what we put here, we could just completely remove the code altogether. This could become this becomes just an expression of type vote type. And what do I want to insert as the expression? It doesn't matter what it is because it is unreachable by definition. So the result of the evaluating the expression really doesn't matter. Oh, that's something I might want to carry in the context. I might want to carry that if the previous statement was resolved in a panic, then everything in this current block is now unreachable. Yeah, I might want to do that. Would that mean that I would need to check? Would that mean that I would need to check, like, there's no point in doing any analysis? I think it's still worth doing, like, name checking and all of that check on things that I know are unreachable. I think the unreachability is something that makes more sense as part of the control flow analysis, which is not done in this phase. So I think for now, the value is just going to be given unchanged because type checking will succeed. And finally, at long last, if we have whatever is left, that is an error, because there is no way at runtime this value will be correct. It's not a panic. It's not a type of parameter. We know its type. It's not an int. It's not a character. It's not a boolean. It is not any of the possible things that could be converted into an enum. Report error. Okay. This is the case where we have an enum as the source, and we have another type as the target. And here, likewise, I can check. I wonder if I should use just matching a type on the typed expression rather than matching a tuple. I can do that, and if I have, it doesn't matter what a type is, if I have an int literal expression here, I can just cast that integer, but I guess this becomes this here, that I will be able to just inline. That's the constant unfolding. Perfect. And if I don't have that, that just means that the value is not known at this point. But we know that it is an enum because we have resolved this as an enum. We don't need to check the composition of this. This just becomes a runtime cast. Which cannot fail, actually. If we have a valid enum, if we have a successfully constructed enum, and runtime checks have checked that this is a valid int, whatever it is, it can be converted into the result. Oh, but how it is converted will also be something that needs to be inserted at runtime, because an int, a character, everything, making sure it's the proper value. No, I think it's fine at this point. I think it's fine at this point. So in this case, we have something that is we know is a valid enum and a target type. I still need to check the target type, I suppose. Yeah. I don't need the result expression here at all. What I need is the I need the resolve target type. I'm gonna do it the other way around. So if I have this int literal expression, and I am going to int type, that works. Or do I want to do this? How do I want to do this? I'm going to do it differently. I'm going to do it the target type first. Resolved target type. Okay, putting the int type first. And now I can do, I am going to an int type, which is valid from an enum. If I know the int at compile time, unfold the thing. If I don't, but I know I'm going to an int type, then this will be to do insert runtime cast. Wait, I don't need to do a runtime cast at this point. It will always succeed. So this is a value, and the result will be pure int expression of this. Not int expression, that's incorrect. That's a typed expression of type in type, and with the value, because this actually makes a constant expression, which isn't what we want. Now I can duplicate this for character type, boolean type. If we have literally any other type as the target, it doesn't matter what the expression is, it will never be a valid destination. Report cast error. And finally, the last one, we have not an enum to not an enum. And the only things we support at the moment are int, boolean, character back between one another. And I think I have no choice at this point but to express the full combination. Yeah, I think I have no choice. Actually, this int value can go away. I think here I have no choice. That's going to be ugly. So I need two things. I need whew, the resolved source type and the resolved target type on top of the expression value. And now I have to handle all of the cases, because if I am targeting an int type, and it doesn't matter what the type I have as the source type is, but I know I have an int expression, I, then this cast obviously succeeds, and the result is pure int expression I. If I have an int type and I don't know what this thing is, but I have a character expression, well, I don't know, I don't care what it is, C, then it is guaranteed to be pure int expression of the odd value of R of C. And if it's a Boolean, to enum from enum of this Boolean. Now, if we don't have a compile time value that we can simplify, if we are in the case where we want an int type and our source is an int type, it doesn't matter what the value is, the result will be a valid cast, and this will be a typed expression of type int type with this value. That is also the case for a character type and Boolean type. Finally, if this is an int type I'm targeting, and Could I avoid all of this? Could I avoid all of this? No, I can't because of the constant time unfolding. God. If it's an int type, but the source type is any other type, that's invalid, and we can report a cast error. And now I just have to duplicate this a few times. Although I suppose I don't need to handle this at this level. If we don't match any of those, we won't match any of the others, and therefore I can have one catch all at the bottom here. Up, there we go. Okay. That is the correct structure. I'm going to align things vertically for more readability. In those three cases, we can do the cast, but this is now a character. This is now a Boolean. What have I done for compile time cast to Boolean? Have I handled this actually? Oh, yeah, to enum the int value. Okay. Wait. That's wrong. That is wrong. That is a bug. Let me show you what I mean. If I do this, and if I do a to as Boolean, which is perfectly valid as far as I'm concerned, and I run my compiler on this, bam, crash, wrong. That's because this should read int value greater than 0. Casting an int to a Boolean explicitly to enum. Where do I have any? Okay, I don't have any other. That's fine. So that's fixed now. And I can go back to this nonsense. So in the case of a character, if I have an int, that becomes the character from that value. This becomes C unchange. And for a Boolean expression, to a character, does that make sense? No, that doesn't make sense actually. Probably shouldn't handle that one. What did we do for constants? Go back to this. I think for constants, what happens is I am converting from int to an int and then back from the int to the value, which means I don't detect when I'm doing something that is wrong, like converting a Boolean to a character. I should fix that. So let me finish this nonsense and I'll go fix the other nonsense. A Boolean cannot be made into a character. That makes no sense. It's still possible for someone to make like Boolean as int to as a character, but they have to really do that for some reason. So this will result in a cast error because we cannot make a Boolean into a character. And can we make things into Booleans? Yes, that is I greater than 0. For characters, what is a character that's valid as a Boolean? And I'm guessing it's just the ord is greater than 0 as well. Which is just like, this is not the terminating character, basically. I think that's fine. Okay, and all three of them can be converted to characters. So the only one is from a boolean to a character. That's not allowed. So I have to handle that one. But now I think we're done with this. Except, of course, this is just B here. And now I need to redo something like this in the case of constants, which is here. Here. I'm going to need to do this resolved target type expression value of, and I can copy the nonsense I have here. Here, there we go. God. But this is going to be a bit smaller because I don't have to handle runtime value. At this point, all of the things are known. So all of those three make no sense, and I don't have to handle this second argument. Those two make no sense. I don't have to handle this argument. Those three make no sense. There we go. From an int to an int, that's just the int. From an int to a character, that's the ord value of the character. From a boolean, an int is just like a 0 or 1. From an int to a character, that's the conversion here. Character to character, it's the same. Int to boolean is just greater than 0. Oh, are those signed? Yes, I think they are. Different from 0. Yeah, of course they're signed. What am I? No, they're not. They are. The literal values are not signed, but I will fold negation expressions at compile time, which means I can get a constant compile time value that is negative. So yes, different from 0. A character expression to a boolean is greater than 0, and a boolean to boolean is just the same thing. I could avoid recreating them, but yeah, okay. Okay. And now we have handled some of the cast stuff, which is one of the branches of what an expression is in the context of a function. And we have not even done it fully because we have to decide how we want to handle runtime cast and runtime checks. Whew, okay. It is possible that we will decide that runtime checks are inserted at a later point during code generation or during lowering into IR. This is something I haven't decided yet. I think at this point I'm going to make this compile and I'm going to stop for this editing because that's already quite a lot of work. Last statement in do block must be an expression. Yes, this int value makes no sense. I thought I had gotten rid of all of them, but I hadn't. Next, that's this. Not. Yes, it is just car type, not character type. Is that all? Of course not. Resolved target type. Here I don't have the enum type in scope. Is that just the dest enum? No, it's a typed expression. It is the target enum. Yes, that's what it is. Or I guess it's even the resolve target type. Yeah. Okay. It's called I in this context. It's called I in this context. Does it make sense to allow conversion from Boolean to enums, come to think of it? I guess it does for... I guess it does if I have like a small enum which is like disable, enable, something like this. I can easily cast Boolean to it, which is nice. The downside being yeah, I can't really restrict to enum of two values. I think it's fine to let Boolean be cast as enums. I think that's fine. It's weird, but not exactly a problem. Okay. Oh, this is a typed expression. Yes. Ah, because this is not what they're called. This is an int literal exp or something. Yes, that's where it is. So here I'm gonna do a replace of expression into literal exp, but not on all of them. This one, not this one. There we go. I'm gonna have the problem in the other case, I suppose. Oh, this is a fully resolved path info. But I guess I don't need to know the type arguments for this, so I think it is fine to do this on path name. Which just means then if I do this, then I have to match. Yeah, no, I'm gonna do that. Because I am matching on the full type, and that just means now that I am matching on the name, which means I can probably... So void type has to be a match on the full type. Now, if I have any other thing, I need to match on the path name of the expression type. And here I can do this. If it is a type parameter, then this succeeds despite not being a recognizable type. And it is, I don't need to do in this case, it's just pure of this. And the value is the... I guess in this case, I don't need to do this. This is just the resolved expression, whatever it's called, which I think is just, yeah, I think this is just the resolved expression, unchanged, forwarded as it is. And in any other case, at the end, it was not one of the known type paths. It's not a type parameter as the path name. That's an error. That's a cast error. Report cast error, I suppose. Okay. Okay, same mistake here. Actually, I can probably do it this way. In this, I'm replacing expression with literal exp. Okay. I will want to align the arrows. That's good news. Okay, that compiles. Which means I can do a quick check before I stop for the evening. Now, this should no longer be an issue. This should be just true. Yep. It's called T, which is a terrible name. Where are you? T, there we go. Literal expression true. So we no longer have a crash there. That's good. And I think that means we no longer handle if I do this as a character and I have 2 as boolean as character, this should be rejected at compile time because no cast from boolean to character anymore. Yep, there we go. Okay, so what we have done so far seems to be working. But as you've seen, this is partially one branch of the big amount of work that resolving expressions in functions will be. But this is still progress. So I am going to stop here for the evening. I'm going to commit this. I'll make sure to actually publish the videos on YouTube. I'm sorry for being late on this. And yeah, I'll see you all on Thursday. Thank you for tuning in.